We'll start block 2, which is thermal physics. Total 5 blocks are there. Block 2 we will complete in November, block 3 in December, block 4 and 5. So in February we'll finish this whole syllabus. So first, starting with the definition of heat or internal energy. What is the definition of heat or internal energy? Basically, heat or internal energy, it is sum of kinetic and potential energy of molecules or particles. So when we add the kinetic energy and the potential energy of the particles, what we call this, we call that as heat energy or internal energy. So example, you have a container which is having say 6 particles. First particle having 2 joules, the second particle is having 3 joules, the third particle having 5 joules, ten joules, 4 joules, and example 2 joules. So when we add the energy of all the particle, like particle A is having energy of 2 joules, particle B is having energy of 3 joules, particle C having energy of 5 joule, D is having energy of 10, E is having energy of 4, and F is having energy of 2. So when we add these energies, that's 2 plus 3 plus 5 plus 10 plus 4 plus 2. So what it will give? The sum of energies of all the particle. Example, in this example, we have 10, 20, and this 26. So we have 26 joules. So what is the heat energy or internal energy? The heat energy or internal energy is 26 joules. The SI unit of energy is joules. Which is denoted by capital J. This we already discussed in thermal in general physics last topic, energy. In that part I discuss what is internal energy or heat energy. Now topics which are related to this heat energy. The first topic is known as the thermal capacity. What is the thermal capacity, or also called a heat capacity? So thermal capacity or heat capacity, it is amount of energy supplied or removed from the object so that its temperature change by 1 degree centigrade or 1 Kelvin. Degree centigrade and Kelvin, these are the units of temperature. So what is the thermal capacity or heat capacity? It is simply the amount of energy which we require to change the temperature of a given mass or of a substance by 1 degree centigrade. Example, you have a substance and the temperature of this object is say 30 degrees. You want to increase the temperature. So if you want to increase the temperature, you will supply energy. So if you are supplying energy, example, you supplied 2000 joules. So when you supply 2000 joule, what you observe? You observe that the temperature of this object changes from 30 degrees centigrade to 31 degrees centigrade. So how much is the temperature change? That's 1 degree. So how much energy we supply so that the temperature of a substance change by 1 degree, that energy which we supply, what we call this energy? We call this energy as thermal capacity or heat capacity. So definition of thermal capacity you have to learn as well. It is amount of energy required to change the temperature of a given substance by 1 degree centigrade. It can be energy supplied also, it can be energy removed as well. Another example, you have an object and the temperature of this object is 17 degrees. So you remove the heat energy from this object. You remove the energy. Example, you remove 200 joules. So when you remove 200 joules, what you observe? You observe that the temperature drop, because if you remove the energy, the temperature will drop or decrease. If you supply the energy, the temperature will increase. So example, this object at 17 degrees, you remove the energy. So if you remove the energy, its temperature will decrease. Example, its temperature decreases by 1 degree. So how much energy you remove so that the temperature decrease by 1 degree? What you call the energy which you remove? You call this energy as heat capacity or thermal capacity. So heat capacity or thermal capacity, it is amount of energy supplied to object so that its temperature will increase by 1 degree, or it is amount of energy removed from the object so that its temperature decrease by 1 degree. Both cases, the energy which is supplied or energy removed is refers to thermal capacity. Is it clear, the concept of thermal capacity?
Sir, I
So
have a question.
yes, Master.
Sir, when we remove the energy, the value of the heat capacity, that would be negative, or
No, actually it is energy. So negative energy, in terms of sign, negative energy does not, it only shows that it decreases. But in, because energy is a scalar quantity, so negative and positive having not having too much significance. If it was a vector quantity, yes, the positive and negative will make a difference. So
oh yeah, okay,
both cases we will say it is positive.
yeah,
So how much energy, I'll repeat, how much energy we supply so that the temperature of an object changes by 1 degree, that energy which you supply is called heat capacity or thermal capacity. But it is not necessary that temperature will always change by 1 degree. Maybe temperature might change by 2 degrees. So how you'll get the thermal capacity? Example, you have an object, you supplied the energy, you supplied 1000 joules, okay? Originally, the temperature was 20 degrees. When you supply the energy, the temperature changes from 20 degrees to 22 degrees. How much is the temperature change from 20 to 22? That's 2 degree. So what is the thermal capacity? Thermal capacity means amount of energy required to change the temperature by 1 degree. So how we'll get the thermal capacity here? If 1000 joules is causing a 2 degree change in temperature, how much temperature change is caused by, or what is the energy which causes 1 degree change in temperature? So how to get this? Thermal capacity, if you need, is equals to energy supplied or removed divided by temperature change. So energy which we supply here is 1000, and what is the temperature change? The temperature change is 2. So 1000 divided by 2. So what is the thermal capacity? The thermal capacity is 500 joules per degree centigrade. So what is the meaning of 500 joules per degree centigrade? It means you need 500 joules to cause 1 degree change in temperature. When you supply 1000 joule, it causes 2 degree change in temperature. But the definition of a thermal capacity, it is amount of energy required to change the temperature by 1 degree centigrade. So if you want to find the thermal capacity of an object, the formula which you will use, the thermal capacity is equals to energy divided by change in temperature. So if a question is, and the unit, how we will get the unit? As we know, the unit of energy is joules and unit of temperature can be degree centigrade. So it is degree centigrade, joule per degree centigrade, or if temperature is given in Kelvin, so it will be joule per Kelvin. The symbolic representation of the formula, thermal capacity is denoted by capital C, energy is denoted by E, and temperature change is denoted by a Greek alphabet delta. Delta means change, and this is a Greek alphabet theta. What does it mean? It means temperature change. So C is the thermal capacity, E is the energy supplied or energy removed, and delta theta is a change in temperature. So example, you have an object and you supply 5,000 joules. So an object is there, you are supplying 5,000 joules. What will happen? It will cause a change in temperature. So example, originally this object was at 20 degrees centigrade. That's what the starting temperature. That was a starting temperature, we can say T1. Once you supply energy, the object temperature rises. Its temperature change from 20 degrees to 25 degrees. That's the final temperature. If the question is find thermal capacity, so how to find the thermal capacity? Thermal capacity is energy supplied. So energy supplied divided by temperature change. So energy which you are supplying, that's equal to 5,000. And what is the temperature change? It cause a 5-degree change in temperature. So you will substitute in the formula. Energy supplied is 5,000 divided by the temperature change is 5. So 5,000 divided by 5, that's equal to 1,000 joules per degree centigrade. What is the meaning? 1,000 joule per degree centigrade. It means you required 1,000 joules to cause 1 degree change in temperature. Is it clear? From where the 5 is coming, because delta theta is a temperature change. So starting temperature was 20. The final temperature is 25. So what is the temperature change or the change in temperature? The difference when you take 25 minus 20, that will be equal to 5. That's why I substituted 5 here. So the concept of thermal capacity, it means this object, it shows that this object required 1,000 joules before it changes its temperature by 1 degree centigrade. Take the screenshot of this. If a question is which object is having higher thermal capacity, you have two objects, two different objects. You're supplying heat energy. For both objects, you supply 200 joules. The temperature of this object changes from 20 degrees to 25. And the second object temperature changes from 20 to 22. Which object is having higher thermal capacity, A or B? Which object is having higher thermal capacity? The formula to calculate the thermal capacity is equals to energy supplied or energy removed divided by temperature change. So in this example, even without calculation, you can give the answer. How you can give the answer? Because you are supplying the same energy. So the formula is thermal capacity is equals to energy divided by temperature change. Energy is same. Thermal capacity is in numerator, one side of equal to, and temperature change is in other side of equal to in a denominator. So what it shows? It shows they are inversely proportional. What is the meaning of inversely proportional quantities? It means that if I increase one of the quantity, the other will decrease. So both we supply the same amount of energy. I can calculate as well, but without calculation, I can use understanding to mention the answer here. If I supply same amount of energy to the objects, two objects, you can see here for the first object, the temperature change was 5. And for second object, the temperature change is only 2. So what it shows if we have a small change in temperature, then the object will have higher thermal capacity because it will divide it or it is divided by a small number. So in this case, when I calculate, it will be 200 divided by 5. So 200 divided by 5, so that's equal to 40 joule per degree centigrade. And for object B, when I calculate, that's 200 divided by 2. That's equal to 100 joules per degree centigrade. So what it shows when two objects absorb the same amount of energy, the object which show small change in temperature has higher thermal capacity. Is it clear, the concept of thermal capacity? Take the screenshot, then we'll discuss the next another quantity. Thermal capacity or heat capacity having a same meaning. Like sometime in a question they ask, I find thermal capacity, or sometime they say find heat capacity. So you will use the same equation, which is heat capacity or thermal capacity is energy divided by temperature change. Then the second quantity, which is similar to this, is called specific heat capacity. What is a specific heat capacity? It is amount of energy required to change temperature of 1 kilogram object by 1 degree centigrade or 1 Kelvin. So When we talk about how much energy is needed, look, in a thermal capacity, we did not discuss about the mass. Like example, maybe this object mass was 3 kilogram, this object mass is 4 kilogram, but we did not bother about what is the mass. The concept of the thermal capacity is how much energy is required to change the temperature of a given substance by 1 degree. But what is a specific heat capacity? The term specific heat capacity means how much energy is specifically required for 1 kilogram object. Like if you have 1 kg object, and you're supplying energy, say you supply energy of 200 joules, and the temperature of this object changes from 25 degrees centigrade to 26 degrees centigrade. So how much energy which we supply, or energy supplied, so that the temperature of object changes by 1 degree centigrade for 1 kilogram object or 1 kg object, what we call that as specific heat capacity. Here the main difference between them is, in thermal capacity we don't bother about the mass, it can be any mass and we are just changing a temperature. But in a specific heat capacity, we all specify the mass and we mention that the mass should be 1 kilogram. So how much energy is required to change the temperature of 1 kilogram object by 1 degree centigrade? That energy which you supply is simply known as heat capacity. So it can be energy supplied also, it can be energy removed also. If you have another object which is also 1 kg and its temperature is 18 degrees centigrade. So you remove the heat energy, you remove example 1000 joules. So when you remove 1000 joules, the temperature changes or decreases by 1 degree centigrade. So if a temperature is decreasing by 1 degree centigrade and we are removing the heat energy for 1 kilogram object specifically, what we called this energy, we call that as specific heat capacity. So the term, whenever the term specific is used, what is the meaning of term specific? It means the mass is specified and mass should always be for 1 kilogram. So amount of energy required to change the temperature of 1 kilogram object, we call that as specific heat capacity. So thermal reason for having a to distinguish between thermal capacity and heat capacity, because thermal capacity can change, but specific heat capacity will be constant. Because every time, like example, if I have 1 kilogram, a piece of iron which is 1 kilogram. So every time I need the same amount of energy so that its temperature change by 1 degree centigrade. So specific heat capacities of objects is constant, whereas thermal capacity depending on the size of the object and amount of object. So if you have a large piece of iron, it will have a higher thermal capacity. If you have a smaller piece of iron, it will have smaller thermal capacity. But both cases, because if object is same, specific heat capacity will be same. How to calculate this specific heat capacity? The formula. The formula to calculate this specific heat capacity. Yeah, take the screenshot. So example, the formula to calculate the specific heat capacity is energy divided by mass into temperature change. Energy the specific heat capacity is denoted by small c. Heat capacity is denoted by capital C. Specific heat capacity is denoted by small c. Is equals to energy supplied denoted by E divided by mass, which is M, into temperature change. Change means delta, and for temperature it's theta. So you can write delta theta, or even some books you can use delta T also, it's acceptable. Both means temperature change. So C is the specific heat capacity, E is the energy, M is the mass, and delta T is a change in temperature. So C is specific heat capacity, E is the energy which we supply or remove, M is the mass of an object, and delta T is the temperature change. I'll give this example how you'll use this formula to get the specific heat capacity. Example, you have an object, the mass of object is 1 kilogram. You supplied 1000 joules. So that its temperature changes from 20 degrees centigrade to 21 degrees centigrade. So if the question is, what is the specific heat capacity? Specific heat capacity is energy supplied. So how much energy we supply? We supply 1000 joules. Divided by mass. What is the mass of this object? That's 1 kilogram. Multiply by temperature change. Temperature change is also 1 degree. So when I solve this, what I'll get? I will get 1000. I'll get 1000. And what will be the unit? The unit of energy is joule. So the unit of energy is equals to joule. Unit of mass is kilogram, the SI unit. Unit of energy is joule, unit of mass is kilogram, and unit of temperature change, because in this example is degree centigrade. So what is the unit here? It is 1000 joule per kilogram per degree centigrade. What is the meaning of 1000 joule per kilogram per degree centigrade? It means that I need 1000 joules of energy for 1 kilogram object so that I can change its temperature by 1 degree centigrade. So amount of energy which we require to change the temperature of 1 kilogram object by 1 degree centigrade, we call that as specific heat capacity. But for example, if instead of 1 kilogram, you was not having 1 kilogram, you was having 2 kilogram of the same object. So now you have 2 kilogram of the same object. And you supply energy so that its temperature changes from 21 degrees centigrade to 22 degrees centigrade. And the energy which you supplied is 4000. So you supply 4000 joules of energy so that the temperature changes from 20 degrees centigrade to 22. The mass of object is 2 kilogram. So what is the thermal capacity for this object, specific heat capacity for this object? So how to find specific heat capacity? It is energy divided by mass divided by change in temperature. So when I use this formula, what is the energy? Energy I'm supplying 4000. Divided by mass, that's 2. Divided by temperature change, that's also 2. So when I solve, I will also get 1000 joules. So what it shows that this object A, material A and material B are made up of, or they are same materials. If two objects having a same thermal capacity, it shows they are made up of same type of particle or it is same material. So you can see sample A and sample B have the same thermal capacity, same specific heat capacity, but their thermal capacities will be different. Thermal capacity means how much energy is required to change the temperature by 1 degree. So what is the thermal capacity of A? What will be the thermal capacity of A? Thermal capacity is energy divided by temperature change. So energy is 1000, temperature change is 1. So thermal capacity is 1000 joule per degree centigrade. For A, it's 1000. What about B? So thermal capacity of B is 4000 divided by the temperature change, which is 2. So you will get 2000 joules per degree centigrade. So what basically it shows that B store more energy than A. Yeah, actually, this will be for B and this is for A. I was solving according to A and B, other way around, that's why. So what it shows that thermal capacity of a B is 1000, where thermal capacity of A is 2000 joule per degree centigrade. Means B store more energy than A. But because the material is same, so for every 1 degree change in temperature, for 1 kilogram object, we need the same amount of energy. So when you have same material, identical material, they will have same specific heat capacity, but they may have different thermal capacities. Is it clear the idea? I'll continue this explanation next session. I'll share the links when this will end.
So just like each different material has a unique density, so they also have a unique specific capacity.
That's right. That's right. Like each material having a unique density, same thing, unique specific heat capacity.
Okay, sir. Thank you.